As humanity is taking its first steps into the solar system, people have already started to wonder, what's next? Interstellar travel is key to the progression from a solar system-bound species to a galaxy-wide one. There are many candidates for the first interstellar mission, including K2-18b. K2-18b is an exoplanet orbiting the red dwarf star K2-18. K2-18b is an opportune target for colonization, as it orbits within the habitable zone of its star. It is classified as a super-Earth, as it has 8 times the mass of Earth and 2.71 times the radius of Earth. However, colonization of K2-18b is unlikely to happen within the next 50 years. This video will cover the challenges and means of travelling to K2-18b, as well as the physics behind it. K2-18b is approximately 110 light-years away from Earth, meaning that any reasonable attempt to colonization would require speeds at a significant fraction of the speed of light. This means that to send a spaceship there, we must understand special relativity. Let's start with the basics. Special relativity is a theory that explores the relationship between space and time. It is built on 2 main principles, or postulants. 1. That the laws of physics don't change depending on your perspective or reference frame. And 2. That the speed of light in a vacuum is the same to all observers, regardless of velocity. The first postulant is intuitive. You wouldn't imagine the laws of physics break down when you move quickly. The second postulant, however, is far harder to wrap your head around. It is common knowledge that the speed of light is the fastest speed in the universe, but many people don't realize that the speed of light does not change based on your own speed. If an observer flew away from Earth at 99% the speed of light, Earth and the observer would still measure the light to be traveling at the exact same speed. Einstein deduced that the only way for this to be possible was for the time experienced by the observer to dilate, which has since been backed up with experimental evidence. This is described by the formula change in t dash is equal to change in t over the square root of 1 minus v squared over c squared, where change in t dash is the moving observer's time, change in t is the stationary observer's time, v is the velocity of the moving observer, and c is the speed of light in meters per second. Nothing can travel faster than the speed of light. As K2-18b is 110 light-years away, it is impossible for a ship to reach K2-18b within 50 years of Earth's observation. However, for the crew of the ship, it is possible to reach K2-18b within 50 years, as they experience time dilation. By substituting the time, we can find the fraction of the speed of light a hypothetical ship would have to travel to. This is an insanely fast speed, and it is safe to say that with current technology, it is unachievable. This figure also doesn't account for time taken to speed up and slow down. The fastest speed ever achieved by a human-made spacecraft relative to Earth is the New Horizons spacecraft, which was traveling at 58,536 kilometers an hour. At this speed, it would take 17,783,927,839.3 hours, or 2,030,128.74 years for a spacecraft to reach K2-18b. But surely a rocket specifically designed to achieve the fastest speed possible could be more feasible for interstellar travel. There are a few ideas for reasonable interstellar travel. These include solar sails, nuclear propulsion, and ion propulsion. Of these 3 choices, solar sails seem to be the most likely. A solar sail is a large, lightweight reflective foil, which uses solar pressure from light sources to propel itself, like a sailing ship. The reason solar sails are so effective is because they don't have to carry their own propellant. Solar sails have a drawback though, as the force generated is relatively small compared to a traditional rocket, and decreases as the sail gets further away from the source. A solution to this is beam sails, which use an orbital or ground-based laser array to accelerate the ship to significant speeds. While this sounds science fiction, serious research has been done on this. Project Breakthrough Starshot is a concept project where small microsats could be launched at significant fractions of the speed of light towards a neighbouring star. Experts have agreed that a project like Breakthrough Starshot could be completed within 50 years. However, small microsats are a long way from the thousands of tons needed to colonize a planet, and the energy requirements to accelerate a ship that large would be immense. In conclusion, it is extremely unlikely that colonizing K2-18b could ever happen in 50 years. This is because of the high speed required and current technological and economical challenges. Also, while it is technically possible for the crew to experience a 50-year journey, from Earth's perspective it would never be under 110 years. In this video, various equations and ideas have been glossed over for the sake of brevity. If you would like more information, please see the summary sheet. If you've enjoyed this video, please smash that like button, and if you didn't enjoy it, I hear the other button works pretty well too. Thanks for watching.